Alright, so let's take the pattern that we've established with our table of exponents and take it one step further and start delving into the idea of a negative exponent. So let's go back to the first column. In this first column we had talked about how if you look at the pattern mathematically here, that each time we jump down to a row below the one that we were on, we're always dividing by 2. Everything here was powers of 2, so to back this pattern down, powers of 2. And that's how we established that 2 to the 0 power is 1, because the one above it, 2 divided by 2, became 1. So now think about what we would get here. And we're going to think of it in terms of fractions. Well, we ask ourselves again, if the pattern continues and we divide by 2, well, what's 1 divided by 2 as a fraction? Well, that would be a half. Now we take that further. Well, what if we take a half and divide that into 2? Okay, well, to me, the easiest way to think about it is just actually physically think about it. If you take a half a cup and you divide that into 2, you would get a fourth. So then what do you think we would get if we divided a fourth by 2? Well, it turns out we would get 1/8. Alright? So, how about the next row? This one, we were talking about powers of 5. So each time we jump down to the subsequent row, we were dividing by 5. So let's go one step further. Divide by 5. Well, 1 divided by 5 would just be 1/5. Now this one gets a little harder because we don't think of fifths that often, but if we were to divide by 5 again, we get 1/25. And then one more time, 1/25 divided into 5 pieces is 1/125. Alright, and then finally the tens. Here we're looking at powers of 10, so each time we drop down to the row below, we were dividing by 10. So 1 divided by 10 is 1/10. What if we were to divide by 10 again? What's 1/10 broken up into 10 more pieces? Well, it'd be 1/100th. And then one more time, be 1/1000th. So now once again, what we're trying to do is we're trying to establish a pattern here, something that we can use to figure out how to calculate negative exponents. So take a look. Here on this first column, I've noticed we got 1/2, 1/4, 1/8. It's always 1 on the top, so I'm looking at 1/2, 1/4, 1/8. And I kind of noticed with each of those, there's a connection between my ones with positive exponents. Here it was, if I look at these two, here it was 2 to the first power was 2. Here, 2 to the negative first was 1/2. If I look at these two and compare them, 2 to the second power was 4. 2 to the negative second power was 1/4. And then 2 to the third power, and 2 to the negative third, 8, and 1/8. So there seems to be this pattern going on here, except the numbers are just reciprocals. Well, does that hold true in the other rows, or the other columns? Well, if you take a look, they do. 5 to the first power, 5 to the negative first, we had 5 and 1/5. 5 to the second and 5 to the negative second, 1/25th and 25, and same thing here. And if you look at the row of the tens columns, the same thing. 10 to the first, 10 to the negative first, these numbers are reciprocals, 10 and 1/10. Here we've got 100 and 1/100th. Here we've got 10 to the third, which is 1,000, 10 to the negative third, which is 1/1000. So we end up getting this rule that says anything with a negative exponent just ends up becoming the reciprocal. So if I were to say it something like this, n to the power of negative x turns out to be, so is the reciprocal of, oops, let's see here, there we go, of n to the positive x. So if I were to give you a problem like 7 to the second power, which we know is 49, the only thing different by doing 7 to the negative second is that it's still going to be 49, except it's going to be just the reciprocal. So we just flip it, 1/49. If I gave you something like 3 to the third power, which we know to be 27. If I make it 3 to the negative third, I know it's 1 over 27. Alright, so what we've done is we've established this idea that a negative exponent is just about the same as a positive exponent, except the answer that we get is just the reciprocal.